Okay, pass. It's high time we solved the second question we were given as a take home in our previous lesson on the law of constant composition or definite proportion. So, yeah, was a question we were given. Two samples of CO2 gas were produced first, one by heating strongly calcium tricarbonate, and then next by heating carbon and excess oxygen. Analysis show first 5.2 gram of CO2 contains 1.42 gram of carbon, 4.3 gram of CO2 contains 3.1 gram of oxygen. Now, does this show the law of constant composition? So, now this whole analysis, does it show the law of constant composition? That's a question. So, first of all, we're going to bring out our table. This is our table. First of all, we have the samples here, and then we're talking about CO2 gas, and so for that, we're talking about CO2 gas. We have carbon here, and then we have oxygen. CO2 is made up of carbon and oxygen. So the first sample, and then the second sample. So the first sample, we have a 5.2 gram of CO2 gas. Don't forget the law, regardless of the method of producing the CO2, if it's truly a pure sample of CO2, it doesn't change the composition of CO2, regardless of the method we use for the production of CO2. So that's why you're trying to ascertain. You're trying to get to know if this obeys the law of constant proportion. So let's say 5.2 gram of CO2 contains 1.42 gram of carbon. And then after that, how much oxygen do we have? We're just going to do the mass. 5.2 minus 1.42. 5.2 minus 1.42. I'll give us 10 is 8, is 4, is 7. You have a 3.78 gram of oxygen. So the next result we got from the different method of production, the first one was gotten by heating strongly calcium tricarbonate 4. The second was gotten by heating carbon and excess oxygen. So let's see if we got the same sample of CO2. So 4.3 gram of CO2 contains 3.1 gram of oxygen. So if 4.3 gram of CO2 contains 3.1 gram of oxygen, it means how much mass of carbon do we have in this very portion or in this very sample? 4.3 minus 3.1 will give us 1.2. So this is 1.2 gram of carbon. So and how do we get to know if this law obeys if this whole experiment obeys the law of constant composition? The science time we solve for that, so we're going to be checking the percentage, that percentage or the proportion or the ratio of carbon to oxygen in each of the samples. So first of all, carbon, we have a 1.42 gram of carbon over 5.2 gram of carbon times 100 over 1. We're going to be doing that. That's for the first sample. So the second, oxygen, you have 3.78 gram of oxygen over 5.2 gram of oxygen times 100 over 1. So that's that for the first sample. Then for the next sample, we have carbon, 1.2 gram of carbon over 4.3 gram of carbon times 100 over 1. And then oxygen, we have 3.1 gram of oxygen over 4.3 gram of CO2 times 100 over 1. So quickly, our calculator will help us to get this off quickly. So 1.42 times 100 divided by 5.2, that will give us 27.3%. 27.3% is approximately 27%. So the next, we have 3.78 times 100, 3.78 times 100 divided by 100, divided by 5.2, I beg your pardon. We have a 72.69, 72.7%, then approximately 73%. So it means we have more oxygen in carbon dioxide than carbon itself. So let's see if you're going to get the same composition, the same ratio as what we have here. So let's see the next sample 2. Let's see the amount of carbon. Carbon is 1.2 times 100, then divided by 4.3. That will give us 27.9%. 27.9%. That's approximately about 28%. Yeah. So next we have a 3.1 times 100 over 4.3. That's 72.09. That's 72.09%. 72.1%, or let's say 72% approximately. So we can say these two samples contain the same amount of carbon and oxygen, regardless of the fact that the difference there are just marginal. That means they are both pure samples of carbon dioxide. That's what it shows. If the first sample, we have some 27% of carbon, 27% oxygen, 73%. Second, 28%, barely 28% to 27.9%. Oxygen, 72.1, about 72%. So it means this whole experiment obeys the law of constant composition. As simple as that. So if you got this question solved also, you got it right, it means you understood what we did in our previous lesson on the law of conservation, on the law of constant composition, I beg your pardon. At a very point in time, during the content of today's lesson, if you found this lesson resourceful, please subscribe to the very channel at EduMosaic. Please follow me also at Revelation Hub on Facebook, and please share this lesson with others. See you in the next lesson. Thanks.